Hello, everyone, and welcome to Learnable Computer Science. Today, we're going to be going through inheritance, which is a subtopic of object-oriented programming, which we have finished in the last class. So if you haven't watched object-oriented programming before, please watch that before this, as this is entirely dependent on object-oriented programming. So let's get into it. So basically, what exactly is inheritance? So it's not what you think. Inheritance is a coding term which basically allows one class to use information from the other class, and it creates a hierarchy of classes. Basically, it allows one class to get information from another, which will save code and will make code more readable. And I just want to go over like the actual definition. I just want to basically say it allows one class to get information from another class in simple terms, but the actual definition is it is a mechanism that allows you to create a hierarchy of classes that share a set of properties and methods by deriving a class from another class. That has a lot of weird terminology, but like basically what you need to know is there's one class here, there's another class here. This class gets information from that class so that that class doesn't need to get information. So that class doesn't need to make its own information. It can just use the information from above. And yeah, what are the advantages of this, right? Like it may seem like we're just making it more and more complicated, but like inheritance is used everywhere in Java courses. I mean, it's used everywhere in general. It's used in Python, it's used in Java, it's used in JS, it's used in a lot of like almost all languages. And the main reason for that is code reuse. Like this is very, very crucial later on, because it may seem now like the more lines of code, the better, like the more complicated your program is. But when you start to code actually for like a really complicated class or for an internship or for a job, the less code that you write, the better. Because the less code that you write is the more simpler to read, right? And for code reuse, this is crucial for memory, and it's also crucial for data management, which is very, very important as you go more and more in depth into computer science and get a job. So that's why inheritance is basically used everywhere to save as much code as possible so that they can reduce their memory, make it more readable, and make it as simply and make it simplest as possible for the other programmer to read it. And it just makes more code more understandable, because you clearly know the information is getting from here. Like if this class has some information and this class gets information from this, you clearly know the information that this class gets is from here. There's no need for you to look around everywhere, or there's no need for you to copy that same exact code again and waste a ton of space. So that's why it's super, super important. And again, this is like this uses object-oriented programming, like basically 90% of object-oriented programming, except like with like a few other tweaks. So if you have not watched the object-oriented programming video, I highly, highly recommend, please watch that before this. Okay, so there's two types of classes for the topic of inheritance. There's a super/parent class, which for simplicity's sake, I'll be calling it the parent class. And there's also a child class. So basically, the parent class is a class that's being inherited from. This is the class that has all the code in it, and you want to reuse that code. It can also be called the base class, but we won't call it that. So it can be called a super class, parent class, and the base class. The child class, however, is the class that is inheriting the code, while the parent class is inherited from. Child class is inheriting the code. And this is the class that needs the code from its parent class. So instead of rewriting the code again, you can just make this child class allowed to reuse the code that was already written, which will literally save that code from being written all over again. So if you have code that's like 200 lines long, you want to reuse that code. You don't want to copy that 200 lines again into this. That is poor design of a class. And it's also called a derived class. So basically, to sum it up, the parent class is a class that's being inherited from, and the child class is a class that's inheriting the code. And you see examples here. The parent class person. This is exactly what we've been working with. So we've been automatically writing parent classes this entire time. But the thing is, if you want to reuse that code, we do class student or whatever the thing may be. And if you want to inherit from the person class, you have to put a parentheses, and then inside the parentheses, you have to put person. This basically indicates to Python that you're making a class called student that's inheriting from person with the parentheses then. Okay. And another really important relationship is the is-a relationship, right? So this is how you determine whether a class can inherit from another class. You put the inherited class on the top, and then you put the inherited class, and then you put the inheritable class. So the inheritable class is on the top, and the inherited class is on the bottom. Like you see here, the parent class and the child class. So for example, if you have a class called automobile, and you have another class called Ford. Automobile is cars in general, and Ford is a specific brand, right? So this is the parent class, do you agree? The parent class is this, and Ford is a child class. The Ford takes some properties from the normal car, but changes some things on their own. That's what every car brand does. So Ford is an automobile, right? An automobile is not a Ford because there's many other automobile brands, right? So an automobile cannot be a Ford, but a Ford can be an automobile. And this is also for the same it's also for like other examples as well. Like a dog is an animal. An animal is not a dog, right? Like there's multiple animals that are not dogs, right? So a dog is an animal, a computer scientist is a person, and an employee is a worker. So the is a relationship, the class on the left of it is the child class, and on the right of it is the parent class. So for example, a dog is an animal. Dog is the child class and animal is a parent class. Hopefully that makes sense. So from the is a relationship, you can easily tell whether this design is correct or whether which class is the child class and which class is the parent class. Oh, well, I guess you have the answer. So here, we have two classes. We have a person class and we have a student class, basically what we did before. So we have the constructor here. Hopefully this is getting a little bit more familiar to you based on the practice that we did last class. Here we have self dot dash dash first name is equal to f name, and then self dot dash dash last name is equal to last name. These are the attributes, if you remember that or not. And this is the additional functions. This is the additional function, and this is the getters. Okay, and we have the student class, which have this is their constructor. But you see here, right? The person dot init. You have two inits back to back. How does that make sense? Well, this is very important. Class student parentheses person, right? This basically indicates that student is a person, right? Because you're inheriting from person. That's because that's the main point of the parentheses. So here we have the normal constructor, so it makes sense. But now we have person dot init self f name last name, right? So basically what this does is, you know how if you go back to the person constructor, it has the self f name last name, f name l name. We just call that, but put in its own variables, which is very, very cool. So here, right, the student class still has a first name, last name, and grade, right? They are a person. A student is a person. A student has a first name and a last name. So that's why they have that's why you can ask for all of these, and then you can just pass in the parameters that you cannot use on the student class, and use the person class. So person.init self f name and l name will call the person init class, which is here, and I'll use this constructor. So when you make the student class, it also makes the person class as well. And it uses code from both the student and the person class. Hopefully that makes a little bit of sense. That's actually super cool. But and then we have and then on the bottom we have another function where we have like print student, right? And inside here we have person dot get f name self, person dot get l name self, and self dot grade. So basically, we can call our methods from the student class from the parent class. For example, person.getFname. Person.getFname is a function in the parent class because we anyways initialize the person class, right? Because we made a new object person.init, and we passed in the first and last name. So when we're creating the student class, we create the person class, right? So that means all these methods will also be activated. That means then we can do person.getFname, okay, which calls this method, and I'll return the self.first name. So we'll replace it with that. Then your person got get l name. So you call this from here, which is this function. So we'll return self dot last name. So we'll replace it with that, and then self dot grade. You're basically printing out the first name, the last name, and the grade, which is super, super cool. Because for student, right, you already written a class called parent. If you want the same exact functionality, you have to rewrite all of these methods into here. But instead, you are being smart about it and you're using the code that's already being written to maximize your code efficiency. So that is why inheritance is absolutely important and key and crucial. So here, if we have x is equal to student John Doe Jr. and say x dot print name. So x is a student, right? So it's making a new student, right? This is making a new student. But doing x dot print name, there's no print name function here, right? That's interesting. But if you look at the person class, there is a print name function, and it calls that method. So for simplicity's sake, imagine the student class when it's inheriting from the person class. All of these methods, 1 second, please. My bad. So all of these methods just get copied into here. Just imagine that, okay? The student is inheriting from person, so all the methods from person will be here as well. So just imagine all of these methods just teleported to here. And then there is a print name function then, right? So then you do x dot print name, and it just prints first name, last name, so John Doe. So now it prints x dot print student, so now it's first name, last name, and then grade. So it's junior, because the junior has been printed up. Oh, so basically the new topics here are basically to call the parent class constructor, to call parent class methods, right, like these, and also to call methods explicitly in the parent class as well, like the print name, which is not exactly there, but like all these methods just get teleported to here. So then when you call x dot print name will be in the student class. So basically the student class inherits all the code, so it has all of these functions in it. Hopefully that makes sense. If you need any help with this, please feel free to email me at salalatkanamuri@gmail.com, or you can join the weekly tutoring sessions which we have going on in order to help with Python and astronomy and more. So let's get into coding. So please open VS Code or any of your using IDEs that you've been using for this entire time. So let's code. So let's create a computer scientist class and a person class. So let's first create the person class. We already kind of looked at this before, so hopefully it won't take that long. So class person. So you do the init function. And then we call self first name, last name. So now we can just simply say self dot first name. Oh, remember we always have to do the dash dash or the underscore underscore is equal to first name self dot last name equal to last name. Okay, so now you have to make getters like getter functions. So define get first name. You have to always put self. And then this is all review from last class. I mean, this is all review from object-oriented programming. So hopefully this makes a little bit of sense now. So just return self dot dash dash first name. Yeah, get last name self return self dot last name. Okay, now we did the getters. So now let's do like an additional function if we want to. So we can just do hello. Then we can say print hello, I am a person. Okay, now we have finished the person class. Now let's create a computer scientist. So class, now this is where we get into new stuff, so I'll go a little bit slower. So class, computer scientist. Okay. Now we originally put a colon here, and then just continue on with our normal initialization, right? But the thing is, computer scientist at the end is a person. A computer scientist is a person. So that's why we can use it inherited. So that's why we can inherit from the person class. So let's do person. This basically tells Python that a computer scientist is a person. So just put the name, put the parentheses, put the parent class inside of the parentheses, and then close it off with a colon. Okay, so a computer scientist has a first name, right? Because they're still a person. Last name, they have that's all it for a person. So now I was going to specifics for a computer scientist. So a computer scientist has a computer, and I think first name, last name, computer, and a badge. Let's just say badge, because when you're in like a computer science job, you'll have a badges with you as well, or company. So you could say company work, or you could say job. Okay. Now let's do person dot dash dash init self first name last name. Okay. Basically, what we did here again, like I'm just repeating this again so that it ingrains in your brain, is that you have first name and last name, right? A computer scientist still has a first name, last name, right? But you just use the person constructor and call and just pass in the first name and last name onto here so that you make a person class as well as a computer science class when you call the computer scientist class. That's basically what I'm doing here. Just making another person object so that you can use these methods inside of here as well. Okay. And then we can do computer is equal to computer, and then self dot dash dash job is equal to job. Okay. Cool. So now let's do the getters for the new um for the new attributes that we have defined. So let's do define get computer. Remember to put self again, then return self dot dash dash computer, then define get job self, and then you return self dot dash dash job. Okay, we did the getters and setters. So now let's utilize everything that we did. So we could say, we could just do the reproduce function. Hopefully you remember what this is. This is basically the when you just say print computer scientist, it will just print out everything like the way you exactly want it to instead of just putting random letters and numbers. So this is how you make a reproduce function again. So you do return name plus, I think we could do commas here. First name, person dot get first name, person dot get last name, computer, and then you can do self dot dash dash computer, and then you can do job title, and then you could just type in self dot dash dash job. Okay. So basically what I've done here, I think this is parentheses. Basically what I've done here is I made like a reproduce function, which again, when you say computer scientist and you just print it out normally, it will print this instead of saying like a random letters and numbers. So when this is getting called, I'm saying name, and I'm concatenating the person dot first name, person dot last name. So now we're using this code, right? We're using this code, and then we're doing computer is computer, and then job title is job title. So this part is pretty familiar, but this part I'm just calling person dot. Okay, so now let's see if it works. So now let's just say scientist equal to computer scientist. We'll just say John Doe computer. Let's just say he has a Mac. And let's just say job title, he's a manager. Okay. So now let's do print scientist. Okay, so let's run it. Ooh, okay. This is one thing I forgot, and this is very important for you as well. So whenever you're calling the the inherited methods, you always have to pass in self. If you remember before, right? We never really had to pass in self, right? Because that was more of like a thing that we just put for the functions to just put it there. Like we don't need to know why it's there. But the thing is for here, right? What this is doing is this is telling us to put self even in these functions as well. So if you put self like this, now the code will work. But like you may be asking like, why? Again, you can search that up. That's one very important skill in computer science, right? Especially to read this error, like person missing one positional argument self. This clearly states that we're missing argument called self. But again, these are like the kind of These are like the kind of practices that are really, really important for you to develop, which we'll practice more in the next class. But here it's really important. One, look at the arguments. Like it's very common to get errors. And second, to kind of understand why something works, right? So this is because you made the person class, right? You made the person class inside of an object. So that's why you have to pass in the self to indicate that you're still using the same object. So that is the reason why. So if I run it, let's look at this. Type error, dot stir, return non-string type tuple. Okay, that means we have to use the plus. I thought I can use like the commas, but I guess I have to use the plus. So I'm just gonna add spaces. And then okay, and then we just this works. Okay, finally. So name, John Doe, computer, Mac, job title, manager. So we have shown that this code works. Okay. We made a person class and we made a computer scientist class. And this class inherits from this class. And the one difference, the few differences that we have is one, it initializes the person class and it also has ability to call methods from the person class as well. I can also say scientist dot hello. See, it automatically puts it in. It already knows that it is part of the student class, which is super cool. So if we press enter, parentheses, and now we can say, now we can run it. It prints out this, and it says, and then it prints out, hello, I am a person. Because at the end, computer scientist is a person. So again, this is like another topic. This is called polymorphism. We won't go into that in this course, but just make sure that when you're inheriting something, this method is basically copy pasted into this method as well without actually using any code. So just imagine this method being copy pasted here as well. But here, we don't need to write it. It's automatically doing so, and it's automatically saving the code to do so as well. So that is the beauty of it. Okay. So let's go back to the slides and let's go through the homework. So you have one homework for this class. So it's basically to create two classes, dog and an animal. An animal is the parent class, which should have an age as an attribute. And it has a get age method and it has a make sound method that prints out I am an animal. And then we have a dog class, which is a child class, which should have a number of teeth attribute and should get the age and initialize the parent class, and which is the animal class. And then it should also have a bark method that prints out bark. So it's basically what we've done here. It has, instead of first name and last name, it has an age attribute. And then we just replace this to I am an animal, right? And then here you just get the age and the number of teeth. Just get number of teeth, and then you just have another one called bark. So it's basically what we already done before. So that's it for this class. You have done an amazing job because this is some really, really complicated stuff, but you all have managed to get through it. So this is a huge, huge accomplishment. So give yourself a pat on the back. You basically finished all of the important curricula of this course. But stay tuned for the next 3 classes. We only have 3 classes left together, which is crazy. Time flew by very quickly, but please finish the homework. You made significant progress. Keep continuing to grind for the last 3 weeks, and I'll see you in the next class. Bye-bye.